Hello everyone, this is Vivian. I'll be explaining to you the sixth experiment in our compiler lab today. So basically the sixth experiment is all about assembler and how it generates a executable object file at the end. So let's take a look at the program which I've done in NetBeans. So initially in the main I've initialized the hash table op table as ready op table and a new hash table and buffers also to read and write. So the beginning of the program is as such. We have okay, if the line contains start, then I'll have a string which splits, so I store it as string C and it'll split wherever it has spaces, and the title will be stored as C0, so that's the first part, which is the title. And if c.length is equal to 3, that means it is the length, because the third part is usually the length of the program. And then we'll start and it will be stored as integer.parseInt. We'll convert it into a number which will be stored in C of 2. Next, if it's not like that, else start is equal to 0 and else is equal to start. Okay, next, if it contains n, the count will be incremented by 3, lc plus 3. Okay, else if it contains another end, we will write that and store it in a hexadecimal string. Okay, so we have another for loop which I created as if in the for loop, if line is equal to br1.read line is not equal to null, and if the line contains start, then I'll print starting with h and the exponential operator, which means it's the header, start from the header, and the title, whichever string I've stored it, and the length also will be added at the end. And else if it contains n, e plus the operator and the hexadecimal string integer dot to hexa string, I'll start. Okay, else lc is equal to pass2, so we'll send it to pass2. Okay, next we have a private static string to 6, which actually stores a string word. So I put another for loop here where int x is equal to word dot length and x should be less than 6, so the maximum size is only 6. And I'll word equals 0 plus word, then I'll return the word. Next we have another function which is pass2, where it contains a string line, hash table operator and hash table symbol, int lc and int start. So here I'll generate the object code starting from the text record. So t, the operator, plus 26 integer.toHex string plus 03 at the end. Then I'll use line.split to separate them again. And if op.contains key C of 2, then I'll generate the opcode, which as such object code plus another operator to 6. I'll get plus op.get C of 2 plus integer.toHex string sim.get C of 3. Okay, next it'll generate the object code, and if it's a reserved word, the count will be multiplied by 3 into integer.parseInt C of 3. If it's a reserved byte, it will be incremented by 1. If it's a word, it will be incremented by 3, and I'll return the LC. And lastly, we have this pass1 sim table update, which contains string line, hash table operator, hash table symbol, int lc, buffered writer. And it'll actually again line.split will split the wherever it has spaces. And if op.contains key of C0, if it contains another key, and if this C of 1 matches any symbol A to Z, and again if it does not contain key, it'll sim.put C of 1, 0. If it already contains, it'll just print label already exists. And else invalid label name. Okay, if it contains a word, it will be incremented by 3. If it's a reserved word, it will be multiplied by 3. It's a reserved byte, it will be incremented by 1 again. then I'll return the LC. So let me just show you the text where I've stored the program. So we have here copy start 2000, so the starting address will be 2000, and we'll load alpha, store beta, and alpha reserve word is 1, beta reserve word is 1, and n. So let me just run this program and show you. So once you run, this object code will be printed as the output. So that's all for this experiment. Thank you.